Hi, I'm Adam Simmons with Project Geospatial and the host of the Geospatial Frontier. I want to welcome everybody to the Advanced Analytics Roundtable panel. But before we get started, it is my honor to introduce the moderator for this session, Mr. Keith MASBACK. Mr. MASBACK is the owner of PLUMRUN LLC, providing advisory and consulting services to leading edge companies and government organizations working in geospatial intelligence and related fields. He's also an active early stage investor and was recognized as the Geospatial Ambassador of the Year at 2019 Geospatial World Forum. Prior to the founding of PLUMRUN, Mr. MASBACK spent over a decade as the President and Chief Executive Officer of the United States Geospatial Intelligence Foundation, and over 20 years combined as an officer in the U.S. Army and as a government civilian employee, culminating as a member of the Defense Intelligence Senior Executive Service at the National Geospatial Intelligence Agency. And now, our moderator, Mr. Keith MASBACK, will introduce our panelists and start the discussion.
Thanks, Adam, so much. I appreciate, as always, what you're doing with Geospatial Frontier, allowing us in COVID times to sort of keep intellectually stimulated, keep the conversation going, and make sure that we're all continuing to press forward, because we certainly have more than too much to do. I'm just absolutely thrilled today to be joined by a bunch of brilliant people, and it's will make my job easy because I just need to sort of shut up and let them share their perspectives. So let me quickly let you know who's with us today. We've got Daniela Moody, who's the CTO of URSA Space Systems. Should also thank URSA for being part of putting the Sensor Showdown together and being part of that series. Todd, Mostak, who's the CEO of OmniSci, is with us in spirit, and he was with us a few minutes ago as well, but he'll be back shortly. Jimi Crawford is the CEO of Orbital Insight, and then last but not least, David Potere, the head of GeoInnovation at Indigo. So the idea today is to talk about advanced analytics. The Sensor Showdown, as we often tend to do, has been very focused on the space platforms. They're a commodity. You get launched, it's a tremendous expense. It's a tremendous emotional investment getting assets on orbit. And so when that happens, there tends to be almost a laser focus on that. We know, though, that in order to make it valuable, to put it into the hands of people, the data that comes down from those very elegant platforms, we have to be able to do something with it. It's got to be able to be provided in a way that enables somebody to make a decision or take action. And that is at the crux of what we're going to talk about today with respect to advanced analytics. So, Daniela, why don't you lead us off and give us a little bit of your perspective, please.
Thank you, Keith, for that warm introduction. And it is, as I mentioned before, my great pleasure to participate in this panel. And hopefully we can all discuss and agree on some thought leadership topics around this area of advanced analytics. So as Keith mentioned, I am with URSA Space Systems. And one of the key or core business models that we've had to embrace at URSA has been to grow out of just providing one modality, one type of analytic, into really bringing synthetic aperture radar and business intelligence to the marketplace in a novel way. So three key messages I would like to leave you with. Number one, at URSA, we've had to make, for example, SAR data access easy. We have had to educate the market on the advantage to be had with this timely monitoring of real changes in the physical world. And lastly, we have had to figure out how to bring that decision advantage to the government contractor, to the individual working in a data company, a data scientist, a hedge fund company, bring that timely information in a matter that is easy to understand, to parse, and get information from. And then repeat all of this on a cloudy day, because radar is something that can function 24/7 all day and night. And that has been probably the beginning of our journey into starting to really create a position, if you will, on what the advanced analytics might look like and where we're headed in the future. So to go back to the beginning, it's our opinion that the proliferation of commercial satellite imagery, in particular multispectral imagery, has started quite a bit before other types of modality, things RF, things synthetic aperture radar, other sensors that are currently orbiting the Earth. And we have seen a significant embracement of these multispectral based analytics, probably due to their to the naturally intuitive nature of this overhead camera images. Well, SAR is not that. Synthetic aperture radar is like RF mapping, like other sensing instruments out there. They're not an intuitive, visually pleasing type of data set. So we have had to really think about at URSA, in order to build this business model based on SAR, how we can extract information from SAR data and bring it to the marketplace, to the decision maker in a way that makes sense. And this to us has been probably the focus, I would say, for the last couple of years. It's been extracting information from raw data and bringing that into context to fuse that insight with other sources of information. So the status of advanced analytic, is my opinion. I think what we consider advanced analytic today will likely be something that our children take for granted on their phone a few years from now. And what we've seen, at least what I've experienced, has been a significant focus and growth into advanced analytics for individual modalities, really that edge of capability. We're bringing in a lot more machine learning, a lot more machine augmented, AI-enabled workflows, and we've seen steady and tremendous progress. I think where the future lies is at this crossover domain and starting to fuse the insights between, say, activity monitoring that's being done with SAR data to agricultural type monitoring of crop yields, and then how those ties into economic lead indicators, food security, and other mission spaces that are just now emerging. And what I'm really personally excited about is we have, I'd say, a fantastic next couple of years ahead, one where we will see a lot of growth into this combination of sensing modalities across the electromagnetic spectrum. More and more individuals are reaching out and companies to bridge the gap between fusing insights in one modality to other insights. And we have to figure that part out in terms of infrastructure, algorithms, databases, processing, and so forth. And I think we're still building as a community that methodology, that infrastructure, and ultimately the expertise to do the advanced fusion analytic. But to me, that's going to be the future. And none of these will be possible without the human-machine teams and AI developments that we're all counting on. So for a number of different market verticals, I think we'll see tremendous growth from these fusion advanced analytics. And that to me is a very exciting prospect. So to summarize, I think advanced analytics for individual modalities are maturing at a rapid pace. I think in our case as URSA, even though SAR has been seeing this late start in the US, it is catching up rapidly. There's a number of education and time that we've spent to grow and educate the customer and commercial market into the potential that could be had with SAR data. So I think SAR and SAR-specific analytics are catching up more and more and are making a big impact. And lastly, I'm excited URSA gets to be a key player in developing both the SAR-specific analytics and these advanced fusion analytics that we hinted at. And if you're interested in, you can obviously find more information by contacting URSA. Thank you, Keith.
Thanks so much, Daniela. I think you point out something really important. I spent a lot of time in both the military and the government trying to work on horizontal integration. That was sort of the holy grail, fusing different types of data towards getting better answers, cross-tipping and queuing. I believe there's a tremendous opportunity at hand right now for the commercial sector to take a look at doing those things. And while there are certainly a different basket of challenges in terms of crossing the streams of different companies' proprietary data and trying to sort out where there might be a neutral ground to do some things like that, it is not held back by many of the barriers that we encountered internal to the government. So I'm hopeful that the types of things you just described and beyond are very much in the near future, because all the commercial data sources that are emerging today, when they are able to be added together, when they're able to be fused to help somebody take action or make a decision, it's really going to be a remarkable step forward for everybody, right, across every vertical in the economy, to include some of the traditional national security applications that we think about. Anyway, with that, Todd, I think you're back with us now, and I'd love to hear your perspectives on advanced analytics.
Absolutely. Thank you, Keith. Great to be here with everyone, and most, if not all of you, are familiar faces. Yeah, I think this is an exciting topic, right? So just as a bit by intro, so Todd Mostak, co-founder and CEO of OmniSci, formerly known as MapD, in a nutshell, GPU accelerated analytics, leveraging the power of modern hardware to explore data faster, get insights quicker, and leverage new modalities of understanding data, such as not only large-scale visualization, but also machine learning and data science workflow. So, when people talk about advanced analytics, a lot of people assume that it's just adding ML. And then if you add ML, the ML magic, then instantly everything will be transformed. And, we'll just get answers and the machines can run it all, right? But I don't think it's that, right? If you think about advanced analytics, really it's basically synthesizing the best of human and machine to allow people to get insights faster, find things that they otherwise would not be able to in their data, and be able to make better decisions by leveraging things like predictive analytics, right? And also, it's almost a foil. If you think what traditional analytics is, it's static, it's slow, it's surface level insights. You got your bar charts, your your pie charts, your bar graphs, and you're just getting, say, average revenue or, what was the GDP per country last year. With advanced analytics, literally you're able to dive much deeper, and human can work at the speed of their curiosity, aided by the machine, right? So the human visual cortex is one of the most complex and powerful processing systems on the planet. And if you can allow the machine to surface anomalies, to surface potential insights, and still keep the human in the loop, we find that it's a very powerful combo. It's a very powerful duo, right? And, for all the talk of auto machine learning and such, I think, and there are limited applications where that applies, I still think fundamentally that a human in the loop, aided by the speed of modern hardware and the best of breed of machine learning techniques, is transformational. So this is particularly timely now because we live in the era of quote unquote big data. But what does that mean, particularly for geospatial use cases, right? In the last decade, there's been a proliferation of sensors and devices. Obviously, satellite imagery, but also mobile phones, IoT data. Anything and everything is emitting data right now. And much of it is geospatial, right, or spatiotemporal. But unlike the world of GIS of old, right, where it was how many light poles did you have in a county, this data is often massive, it's often moving. It's not just space, but it's also time. And there are any number of other interesting attributes. So geospatial understanding is a critical but not the only piece of getting the full picture, right? So what this means is that you need kind of new tools and workflows that are able to synthesize multiple data sets with multiple or often hundreds of different attributes. It could be satellite data combined with social media data, combined with location data, combined with Nextrad radar data. There's endless modalities to actually understand a problem, and just using one data source or a GIS frame of thinking or a BI frame of thinking or even a data science machine learning frame of thinking is not enough, right? So these workflows have to be converged. And what we're excited about is we think that there's been a revolution in modern hardware. And there's a lot of things, right? It's not just GPUs, there's FPGAs, there's ASICs, et cetera. But for us, at least, the GPU has been pretty transformational, and it literally allows people to access the power of supercomputing on a budget that even medium-sized organizations can easily afford. And with that, you have a GPU, you can scan massive amounts of data. They have a ton of memory bandwidth, so you can run SQL, you can visualize massive amounts of data. They have a ton of compute, so you can run machine learning on the same data in the same workflow. And then finally, they were built to render video games. So for geospatial data, that's particularly relevant because you can see billions of points, lines, polygons on a map. And you can converge these modes of understanding. So you're not just in Esri doing GIS stuff, you're not just in Tableau doing BI stuff, or you're not just in your PyData stack. trying to do algorithms, you can do it all in the same system without copying data between processes, between memory spaces. And for our customers, both in commercial and federal space, it literally allows them to take data sets, bigger than they ever thought they would be able to work with, and get real-time insights, whether that's a telco figuring out why calls are being dropped in a certain area, or it's doing real-time disaster relief or response effort to COVID-19. I think it's pretty transformational. So, I'm excited to be here, and I think it's a really fantastic topic.
Thanks, Todd. I appreciate that. Raising the point of the different paths forward, how we're able to assimilate technology as it comes along, and not sort of figure out that we've got to change the workflow every time, right? But also not be stuck into sort of paving the cow paths. So it's a very interesting challenge. When is it time for a new paradigm, and when is it time to speed up something that served us very well? And I think that those are just some of the decisions that I guess in some ways we're fortunate to have to make right now, given the riches of technological advance.
The one last thing on that, I think what's cool is you don't have to abandon the old workflows, right? So you can still support full SQL, or you can still support WMS or anything to output to, say, Esri, but you can do it so much faster that the quantitative edge gives you a fundamentally qualitatively different experience in what you can get out of your data. So it can look very familiar, but it's the orders of magnitude speed increases we get can be transformation.
Yeah, I think that's something that we don't talk about very much, but I think that's a really important aspect of this whole discussion. Jimi, over to you, sir.
All right. Thanks, Keith. So I'm Jimi Crawford, CEO and founder of Orbital Insight. When I started this company about 6 years ago, in terms of your intro, Keith, about the importance of making sense of all the data coming down from these satellites, I remember looking at through the partner page at every partner of Digital Globe, and every one of them was a company that took satellite imagery, loaded it onto their desktop machine, and looked at that imagery by eye and made sense of that singular image. And we're in a world, we were then and we still are now, where we're seeing just a tremendous growth in the number of satellites. And that gives us a sort of abundance that we've never had in the history of spaceflight. For the first time, we've got the whole world essentially every other day with Planet Dove imagery, and Maxar, Airbus, and others are launching huge new constellations as well. And in addition to that, there's lots of other sources of geospatial data that are deep complements of satellite imagery. We get AIS data from every ship, connected car data from all the cars running on Star or all the Teslas. We get geolocation data anonymously from phones. So there's this tremendous richness of data. But as Keith pointed out in the beginning, if that data just sits on a disk, it does nobody any good. So if you take an image, and no human or AI ever looks at that image, there could be a man from Pluto on that image, and we'd never know that we were Pluto, right? So you really want to have some way to look systematically at all that imagery, and the human eye is a wonderful tool, but it's fundamentally limited to looking at one thing at a time. So you could spend, when you're thinking about precision ag, you could spend the entire growing season driving through fields in the Corn Belt and see, less than 1% of all the fields. You could spend all day, every day, staring at Walmart parking lots and see, a tremendously small percentage in the number of Walmart parking lots. But what we want to understand to really manage our global economy is all the field plants, all the auto plants, all the fields, all the retail locations, at least enough of them to get a significant statistical sample and understand what we're doing. So the mission statement of our company is to understand what we're doing on into the Earth. And we approach that with every tool we can find, right? So for times when it's cloudy, we'll use SAR imagery. And for the broader spectrum sets of the world where it's not cloudy all the time, we'll use visual light imagery. To understand inside buildings, we'll use geolocation data from cell phones. To understand what's going on in the sea, we'll use AIS data. And our platform allows the end user to in a self-serve fashion, ask and answer their own questions. So, for instance, our customers in Nikkei in Tokyo have run 6 articles now that they, based on Go projects that they themselves created to understand the impact of COVID on Japan. So they can run projects to look at changes in ship behavior, changes in behaviors of individuals using anonymized cell phone data or satellite imagery to look at places like China where there's not as good cell phone data. We've also looked at questions like how fast, like in the early days when we were just starting to recover from COVID, we were interested in how quickly the auto manufacturing factories were coming back online. And there was a lot of speculation in the press about, was Tesla back up? Were the other automakers following suit? And we can look day by day, in certain cases hour by hour, at the recovery of these auto plants from their shutdown due to COVID. We also started looking at all the meatpacking plants in response to a lot of the press about the slowdowns in meatpacking. And again, it's a combination of satellite imagery and anonymized cell phone data to understand these locations around the world. And even crazy things like which California beaches were getting crowded, to get an idea of where COVID was likely to spread during the lockdown. So I think this all shows the power of the analytics and the tremendous power that we as a community can provide. Take those different kinds of analytics, bring them together in one platform, and then the critical last step is to make that really usable to individuals that want to ask and answer their own questions. We spend a lot of time as a company, Orbital Insight as a company, and also as a community, building data sets that we like to talk about, like floating mid oil tanks or retail car counts for measuring the amount of consumer activity. But the real power that we're finding is when the customer can ask and answer their own question. Almost imagine we will, as a community in the future, be able to provide almost a Google search for the world, right? So what's going on in this factory? What's going on in this industry? And that takes a tremendous number of satellites. It takes tremendous computing power, to Todd's point about using GPUs. It takes a tremendous amount of AI, but then it enables the human to ask and answer their own question, and then write whatever research report they need to write, answer whatever question they need to answer, and make whatever decision they need to make.
All right, Jimmy, I appreciate that. David, you expressed some trepidation, right, to be in this crowd and have to sort of clean up on the opening remarks. But I would tell you that in the conversations we've had over time, we never had any shortage of sort of pretty mind expanding topics to talk about. So I'm not gonna allow you to suggest that there's nothing left for you to say in this conversation. So over to you.
Thanks a lot, Keith. I think there are some openings here for some good contribution. I'm delighted to be here today. I stepped into this sector as the co-founder and CEO of Telus Labs, a company that built a business around agricultural intelligence. And we've been at that game humbly here for, I think it's up on 5 seasons now. And so what I thought I might do, Keith, is just share some comments from the perspective of a single sector. And I think that Daniela mentioned the importance of verticalization around really building analytic solutions. And I feel like the last 5 years of adventure have really proven that out to me and the team. We're now a part of a company called Indigo Ag. James mentioned a mission statement. I think it's really cool to be part of a mission-aligned company. Our mission at Indigo is to sustainably to help farmers sustainably feed the planet by harnessing nature. And what's really fun about the food problem, Keith, is it's the largest, oldest factory in the world, and it has no roof. And so we love those kind of problems, right, in this group. And we've been watching for a while now. I will say every year that we've been at this around trying to forecast and monitor the food system, the farmers we work with say it's the strangest year they've ever seen. And so clearly this factory has a big change afoot around the inputs that make our food. And so between climate change and scratching our heads around how to feed an additional 2 billion people before my kids are having kids, there's a lot of challenges around food security. It's probably the security topic of the future, right? Is how we're going to feed ourselves. And, a lot of the topics already mentioned on this discussion today are around whole new, this abundance that James talks about around the kinds of sensors, the velocity of sensors, the richness of detail describing that factory. The challenge we found is just how verticalized the
analytics-ready data needs to be. So what does ARD really mean? If we're setting standards on what analytics-ready data is, ready for whose analytics? And I'll tell you, around the food system, anytime I gather a group of data scientists and remote sensing experts to build models around helping us more sustainably feed ourselves, they're really tough customers. And I'm sure Daniela can testify to this. I mean, the people that are building the formulas, the trade-offs you have to make a remote sensing product ready for game time, a lot of times you're wrestling with, am I going to throw the baby out with the bathwater as I try to get that signal to noise ratio right? And I was talking to the team right before today's panel, and their comment to me was they were guessing that raw data from sensors are processed and reprocessed probably hundreds and thousands of times to generate products that are essentially the same thing, Keith. And so one of the unlocks that we get really excited about is there a future, perhaps through commercial government partnership and a more willing embrace of open data and processes, where instead of reprocessing the same data streams 100 times over, for the same level of societal investment, we could create thousands of these verticalized solutions that are suitable for actually solving problems, and not analytics-ready data, business-ready data. I mean, data that's really able to unlock analyst potential. And just since starting Telus Labs, we were using GDAL 2.0. We were using QGIS 2.18. All those platforms have moved on. 4 and 5. We're on QGIS 3.2 now. So the whole framework for solving problems and building solutions has started to blur the line between being an analyst and writing production-ready code. That's super exciting if you have real access to this stranded data that James is talking about. If you can take out the specialist know-how that's required to get geospatial data ready for analytics, there's this huge explosion in analysts that are ready to solve problems, if only they can get access to the data in ways that are relevant for them. And I'd say the other light bulb for us is verticalization is real. Also, many of these problems are local in nature. And so this idea of generalizing what you learn about South American soy and using it in theory to be at work in India tends to not pay out when you're talking about environmental systems. And so it's going to take just hundreds of actors working in many cases locally and regionally to untap all the full potential here. And so all the more reason to try to find, private and commercial partnership to get this data out at scale. Because it's probably not going to be one company that cracks the code on really important grand challenges like food.
Well, David, thanks so much. When I would be recruiting people to come work, whether it was at the Army or NGA in the national security space, and they'd indicate that they were concerned, or when I later was working on campuses as part of an educational nonprofit foundation, I would often use food security and water security and climate change as sort of a common denominator, and describe that those are major national security issues, right? And that understanding those types of friction areas around the globe, which are happening and will continue to get worse likely, really, really very important at the end of the day as core issues, societal issues, security issues. So that's important. We naturally, because of the nature of this group, we've got some great questions. The first one's a bit of a softball, but I think I'll throw this to you, Todd. Others might want to pitch in. It's a little bit of a yes/no question, but I think, Todd, you can expand upon it a little bit, and you touched on it in your remarks. So this question is, are GPUs mainly designed for imagery or video-based processing, or are those types of processors used for overall scaling operations with large data?
Hey, there you go. No, that's a great question. And, I think there's this perception, and it makes sense, right? Because they're called video cards, right? Or graphics processing units. That still the mainstay or the main workload for GPUs are graphics processing, video processing, imagery processing. But in fact, if you look at the meteoric rise of NVIDIA, one of the main manufacturers of graphics cards, and they've been around for probably at least 2 to 3 decades. Most of the recent growth has been built on not video games, but actually the enterprise data center. And that also includes the cloud. And most of those workloads, yes, there are imagery applications for sure. GPUs are good at, well, for one, you hear a lot about deep learning for imagery processing, like finding cats in videos right on YouTube. But it could also be like, I'm sure James could talk about leveraging it to measure how much oil is in an oil tank or cars in a parking lot. But it goes much farther beyond that, right? So these GPUs are effectively, yes, they have some graphics hardware, but they're really just very fast processors. You know, a modern GPU might have more than 5,000 cores. It could have anywhere, let's see, on a single node, you could have 0.5 terabyte of memory in aggregate running at 15 plus terabytes a second, which is order of magnitude faster than you would see on a CPU node. And so you can actually tackle big data problems. They're general purpose compute engines. People call it GPGPU. And so our technology, first and foremost, was compiling SQL to run on GPUs at kind of the speed of the processor. So if you have 10 terabytes a second of memory bandwidth at your disposal, you're going to be able to process data at a very, very fast rate. Now, you can also do the graphics processing, which is very handy when you're doing geospatial data, which is often, well, it can be raster, or you're producing imagery. You're taking vector data and rasterizing it for visualization. And finally, on the machine learning front, the first big breakthrough was deep learning. Deep learning, deep neural nets, right, which I think gained prominence 5 or 6 years ago. And it's kind of taken the world by storm for not just image recognition, but also speech, voice transcription, speech to text, and a whole number of other paradigms. But more than that, people are now running general purpose machine learning algorithms. So your XGBoost or your even your general linear regression can often be accelerated on GPUs. So it's pretty exciting because they can actually synthesize. They're really a a utility player. They're a triathlete and can do all these things very well that make them very fit for purpose for analytics workflows, in my opinion.
Thanks, Todd. And this is great because the questions continue to roll in. So I keep thinking I know which one I want to ask next. I'll go to this one, probably primarily for Daniela and Jimi, but actually anyone could take a crack at it. Many data collectors, whether they be satellite, aerial providers, are providing some level of their own analytics services, obviously some more than others. Do panelists feel that the market is competitive or complementary, viewed through the eyes of an analytics-focused company? Are these providers your partners and or are they your competitors? Daniela?
Thank you, Keith. That is a good question and a very relevant question in the context of this panel. So the answer is, in many ways, in our case, we have a virtual satellite sensor constellation with SAR in particular. We draw upon other providers as well. I'd say they're really nicely complementary. I believe, at least for the SAR market, it is still an untapped significant amount of potential in terms of what it could do. I think at URSA we've pioneered over the last few years the education, at least of the commercial market in the US, to adopt SAR-based analytics. And I think there's room for a lot of that to grow in terms of the analytic market. So I'd say in some situations, many will use SAR data. We certainly are not the only ones to develop analytics on top of SAR data. I think at some point, I would look at a lot of them as fairly complementary. It's a win for the community. The more commercial entities adopt SAR-derived analytics. And here's an example. So I believe Jimi mentioned COVID type impacts and ways to measure. We have done a tremendous amount of work at URSA to, say, apply our analytics to COVID response. And the reason we were able to do that is, let's say we built our direct measurements, observations of change, activity indices to be pivotable. And when COVID hit, one of the immediate tools that we could go to was, fortunately, a SAR-based data set, right, that is persistent. You can see anywhere all the time. And you can use that to now create analytics that fit that particular need that both government and commercial sector really screamed for in terms of insights. So I'd say, and we've seen now the same thing as the COVID impacts are, I would say, not, we've captured this sort of short-term impact, what's happened now, what's shut down, what's restarted. We have multiple dashboards at this point that we run on the global auto manufacturing industry, also on shipping, oil storage, and in general, we're moving towards this water, food, energy security nexus, because any of those break into supply chains will impact national security at various levels, or regional security, population instability, and so forth. And we are seeing a scramble, may be the right word, from a number of NGO and other entities to find information that is relevant to them now. So I think the real test of using analytics is now to, for a lot of these, whether let's call them competitive mates, but in many cases, I think they're just complementary analytics, and markets come together to say, how, is my analytic relevant to this time of need, and can I pivot it to make it, to turn it into a business intelligence or information that is actually relevant and helps mankind in this time. And I think, COVID has been obviously a very difficult season for everyone for a lot of different reasons. Nonetheless, I think it's created a challenge that we all need to rise to provide analytics and that commercial analytic machine learning support to bring the insights to the table. Because if your analytic doesn't work in a time like this, when should it work? So yeah, I'm curious what Jimi thinks.
Thanks, Danielle. So, the way we look at this situation is as I mentioned earlier, we're very mission driven. So we're starting from the mission of understanding what we're doing out into the earth. And we're starting from the questions we get from our customers. So the customer wants to know, if they're a utility customer, they want to know, is my utility right-of-way safe, and is anybody building new roads and buildings in the middle of my high-tension line, in the middle of the right-of-way under my high-tension line, or is somebody tapping into my oil pipeline somewhere in the middle of West Texas? So they have a particular question in mind, and those questions are highly varied. We go back then to figure out what the right data source is, either satellite or other data source, to answer that question. Now, if you look across the spectrum of satellites, look at a company like Planet. They have essentially 3 different constellations, or 4 actually. They have a Rapid Eye constellation, the Old Doves, the Super Doves, as well as the SkySats. You look at Airbus, they have Pleiades, Spot, and then Neo Pleiades being launched. You look at Maxar, they have multiple different generations of satellites. The old GeoEye satellites are different from the newer satellites, and then they have new Legion constellations being launched. And the list goes on, right? Triple sat, list goes on. So if we have to train a car detector for each of 20 different satellite constellations, and then separately we have to train a truck detector, and separately we have to train an armored vehicle detector, and an airplane detector for bombers, another one for fighters. You do the cross product of those two, all of a sudden we've got to train literally hundreds of computer vision algorithms to mark 50,000 images, right? It gets to be a really large lift. And then you add in the SAR constellations as well that we also work on. It's even larger. So if the satellite companies themselves build some of those detectors for some of their satellites to our standards, I think it's all for the good. I think it's a really nice kind of partnership, because it basically takes the hundreds of CV algorithms we have to build and it takes a few off the list. And as I say, we're interested in the shortest path to serving the customer and the shortest path to answering the customer's specific question about this particular COVID event or this particular utility right away or this particular border crossing. And if we can partner with the satellite companies to get some of the CV for that, like I say, it just gets us there faster. And then there's also other really interesting cases like Airbus Earth Monitor, where they're actually licensing our analytics, both our Go platform as well as our CV algorithm, and using it in their One Atlas platform. So in that case, the partnership is even tighter, because we're actually providing the full analytics platform as well as the CV for their specific satellites that they then use in their platform for their customers to interpret their imagery. So I think overall there's multiple ways the partnership can be struck, but they're all productive for the industry.
David, you have some of that?
Yeah, I mean, from where I'm sitting, Keith, I don't know what the ratio is, but I would hazard a guess that 90% of the dollars get spent on hardware versus data storage, analysis, and processing. So if there's a solution that gets hardware creators more into the, further along the analytics refinery processing, that's what Descartes used to call it, Daniela, like we're in the refining business, right? Then I'm a huge fan, and I think the more of that, the better, because that ratio is surely not set right now around how much is going towards primary data collection versus the kinds of tools and technologies that we needed to actually solve problems with that data.
And David, you bring this is an excellent point, actually, and you're right. With a lot of these data sets, there has been I would say, an earlier push, commercially at least, to provide the analysis-rated data for let's call them across the different market verticals. I think where Jimi and I are seeing now a transition towards is more from not just individual, say, containerized analytic microservices, but more towards this sense making. What is meaningful change? What is meaningful information? And how to even define meaningful? Because what's meaningful to one customer will not be meaningful to someone else. And those are, I look at the entire processing chain as more, I think we're making progress toward more of these end-to-end analytics, but I think there's certainly a lot of room for the community to grow, to take all the awesome hardware outputs that we have currently and the terabytes of various data sets, each with their own intricacies and complications and complexities, in the case of SAR, pun intended, and take that into, let's run some core analytics, and now let's make sense of them and fuse them together. I think that's going to be the holy grail for the GeoIn community, and we're getting there. But I don't think we've arrived quite yet, which makes this all the more an interesting journey for all of us.
So I'm going to conflate a couple of questions here, and I don't think machines are very good at that, by the way. So I just want to point out that it remains a human strength. It gets to the macro level question, right? It's probably come out of all of our mouths, and we say it because we believe it and we mean it. The questions really kind of get to how far along are we on figuring out that line? What do machines do well? What do humans do well? And how do we assign the right tasks to each so that we get a machine plus a human equals a lot more than the sum of the parts, so to speak.
Argue with me, but we've got to be at the beginning. I mean, however you want to design that scale, it's got to be the vanishingly first, second of the journey, I think. But I'd love to have somebody argue with me about it.
Yeah, I've been in this field for a while. I did a PhD in AI a couple decades ago. And the interesting thing is back then, nothing worked. Back then, it was largely a branch of philosophy. We were trying to figure out the nature of intelligence by writing programs, but people struggled to find commercial applications. So it's really interesting that we've at least advanced the field now to the point where people ask the question. I think the very fact the question asked is very meaningful. But I mean, there has been tremendous progress. I mean, back then computers couldn't even play chess, right? Then the best chess player got to be a computer. Then the best checker player got to be a computer. Then the best, to my great surprise, the best Go player in the world got to be a computer. But even today, the best chess player team is a human computer team, right? So we see this across the board. There is a tremendous synergy between the ability to unflinchingly look at detail. To Todd's point about large-scale computers just don't get bored, right? You can have them do the same thing 1 billion times, and they will not stop focusing on it. There's no way a human can come anywhere close to that, right? So there's this. I sometimes describe modern AI as a million well-trained 3-year-olds. So if you had like 1 million incredibly obedient, never bored 3-year-olds, that's what AI does really well today. So things like find all the cars in this picture, find all the trucks in this picture. But obviously, 1 million well-trained 3-year-olds cannot solve a hard analytics problem, cannot figure out what is the intent of this actor in this situation, what is actually going on at a macro level in terms of sense making across COVID response across the U.S. Right, so I think there's tremendous synergies between the scale and attention to detail the computer can do, and then the deeper insights and unexpected intuitive jumps that the human can do.
So, Todd, given the age of your kids, how would you like to be homeschooling 1 million 3-year-olds?
Yeah, you said obedient 3-year-old, and I'm like, yeah, never heard those two words together. But I get the energy part. No, I would second Jimi. In that, I think where AI really makes sense for analytics is surfacing things of interest to humans, often subject matter experts, right? They're not going to, AI is not at the point where it's typically able to make semantic sense of some situation or scenario that's not very bounded and it hasn't been heavily trained on. And the other thing that like COVID-19 has exposed, and people have been talking about this, is that when you have regime changes, when there's suddenly everything is overturned, and yeah, maybe your model was working pretty good for predicting consumer behavior, 6 months ago, but all of that's out the window, right? And in these periods of change, whether it's black swan events, like having a human in the loop who can kind of quickly make sense of the situation. And yes, we will train new models and things will somewhat return to normal. But we're not there. We don't have a how yet, right? Not even close.
I wonder, I bet you, James, you've seen this. The other learning in that direction for us, Todd, was when humans inevitably are in the loop, if you're goal seeking for back-tested accuracy and model performance only, you probably lose. And so what we've found is that farmers and traders need to know why. And so that's been the other surprise for me of putting AI in the workflow of humans. If you don't privilege as well storytelling and scenarios around the machine learning that you're doing, it doesn't matter that you're right because no one believes you. And they're not actually able to, not only, even if they did believe you, maybe they're not able to do what ifs to be able to get to a tangible set of actions. So that's been a real learning for us, is that the Holy Grail is not all about accuracy. There's
tremendous variety in the why, right? And the machine's just not very good at that. So we had one weird case back in the day when we were counting cars at retail locations. We suddenly saw an uptick at a retail location. It turned out the reason was somebody opened up a used car dealership next door and started using the parking lot to park their cars that they had for sale, right? I mean, that's the sort of thing that a human can look at and say, oh, this is really weird. There's all these old cars here. That couldn't be all people shopping at this store, right? So you see this again and again with subject matter experts looking at our refinery data, our petrochemical data, our meat processing plant data. The subject matter expert will look at the output of the anomaly detector, the AI-based anomaly detector, and say, yeah, that's an anomaly, but that one's not, right? I can completely understand what's going on there. It's not really interesting from a business strategy point of view.
This is actually why I've always been shocked at how many, even advanced data science practitioners, strongly prefer a linear regression or some sort of regression. There's a funny line from War Games. I don't know. It's one of my favorite movies when I was a kid. What's the general is like, not going to trust the future of our country to silicon diode. Just kind of funny because it was from the 80s, right? But, I think we're still there, right? Like, I've rarely met anyone who's willing to trust kind of key business decisions to just an algorithm unless it's very, very bounded. And you've seen in the financial services space where that massively backfires, right? When something triggers these bots and they go awry and trade wrong, costs, hundreds of millions of dollars, billions of dollars sometimes.
Yeah, Todd, and that was that's actually one of the things we've definitely noticed at URSA in recent years has been, the more we were able to put particular algorithm outputs into this is the why and start bringing in that contextual reasoning around events, the more customer trust, let's say, and adoption has gone up. And, on the initial question, which was the machine learning now and how far we are in that line. I think, David, we're like on the second of that process. But I will second what Jimi said. We are, the machine is only going to do right now as good as it is trained to do. In many cases, we used to have somewhat unlimited training data set and labels for some modalities, and that was the struggle when COVID happened. So a lot of the behaviors and expectations of behavior are no longer the same. And now you have to really think creatively around what does transfer learning look like? How do we recreate a trusted label data set? Because the reality is your card counting algorithm will still work in the time of COVID or time before COVID. It's more, what does that mean? An activity in one location or increased activity may mean one thing that's very different from, lack of cars, say, parked at the airport because, travel now is shut down. And it's really, to me, until we get to that, the machine able to pull and fuse together adaptively or do this multi-in function that us humans do so well, we're not going to be anywhere close to even trust a little bit more the machine versus the human. I think we're still in a good 50-50 split. But ideally, we can start first of all, I think we still have some limitations in terms of compute. Our brain has a few more orders of magnitude extra flops than the supercomputers, the top ones out there, or at least we haven't programmed it that way. And from a computational neuroscience perspective, I don't think we fully understand yet how the brain completely works and makes decisions. How do I, for example, try to analyze Keith and his background and all these other information and lighting sources where he might be? Those are these indelible qualities to the human brain that are so very, very difficult, I think, to train a machine. So I think for a while, we're going to be limited in our machine learning outputs by how creatively and how well we can train them. But they will only do as good as we can train them to do. And I will echo what Todd said. I have kids as well. They're not doing very well with my training.
All right. So we're in the home stretch here. So be mindful with your thoughtful answers. I think that was a way to just say, like, be short. But
verbose.
Sounded nice, right? So the most recent question that popped in on the subject of advanced analytics, what types of sensors do you see we need to fill a void? What are gaps, right? That I guess sort of offering a lightning round type question, some enduring problems that you each deal with in your respective lanes. That you, if I could only have data about this, it would fill a huge void for us and help us answer, a significant number of additional questions. You want to take a shot at that, David?
I'll be terse. Just to be provocative, for our sector, I think we got it. From a satellite remote sensing perspective, over the last few years, we're there. If we continue this level of surveillance, we could solve huge problems in the food system. What's missing is analytics-ready data and the data storage and sharing capacity and a willingness to work in open ways so that we're not solving the same problem 5-10 times over. But the question that you got was, in my opinion, the wrong question. There is not a hardware sensor data gap in this domain. It's everything else we've been talking about that's holding us back.
All right. Start off with an aggressive answer. Todd?
I think it's just, and I'm not as much an expert as folks here, but I think when we deal with data, it's often the trade-off between spatial resolution and temporal resolution. And you see that in satellite imagery, for example, right? Often the things where you get frequent flybys just don't have the resolution you need to do the more advanced use cases. So I'm sure we'll get there. And I'm sure people on this panel know more than I do on the timeline of that, but I see that come up a lot.
One more second, right?
Right.
So Todd, you're looking for loitering high res, right?
Yes. I think some of our customers do as well, right? At any place, at any time.
Right. Yeah, that's all.
Yeah.
Jimmy?
Leave it at that.
Yeah, so I actually have a very simple request. I actually had the same request for about 5 years, which is sub-meter in all the cities, daily sub-meter in all the cities. And the reason for that is our mission to understand what we're doing on and to the earth. And a lot of what changes on a daily basis in cities is movements of cars, trucks, and trains and airplanes. They're all about the same size, actually, going back to the width of Roman chariot wheels. So since they're all about the same size, we need about the same resolution to detect them all. So we could get daily sub-meters, at least in the cities. We could do a tremendous amount of damage in terms of understanding what we're doing on and to the earth.
All right.
I suppose I was speaking for the rural areas.
That's right.
And so that's essentially, I think it's about 10 meters daily, and we're there, and we're kind of there.
Yeah.
I think from a broad perspective, if we're looking at the, fill in the observations of the Earth across the electromagnetic spectrum, we're getting really close to having that filled in terms of the sensor and the hardware. I think what is missing is the ability to do multi-look, multi-resolution, even across the sensor, or sensor modality, I should say, tipped and Q by events, and also start doing the cross wavelength type fusion analytics. Those all against go in the analytic and the creation of I would call them the software platforms, and the architecture is not so much the hardware itself. So that would be my choice.
So I apologize to those of you who submitted some of these awesome questions that we didn't get to. And maybe Adam can help figure out a way for us to answer them offline and post them somewhere or something, because it would be great to do with this group. So with that, I want to thank you all so much for being here today. I knew this would be fun. I knew this would be thought-provoking, and you guys delivered. And so thanks again, and over to you, Adam.
Thanks, Keith. I want to thank everybody on the panel for participating in the Sensor Showdown, a Geospatial Frontier series hosted by Project Geospatial and partnered by URSA. For our audience, thank you all for watching and contributing your questions. You can watch the recorded version of this session on YouTube or geospatialfrontier.com. Once again, thanks everyone for listening, and see you next time.